we will start with the first chapter, angle and its measurements. Okay. So before we go into it, there are some definitions which are given. So first definition is, what they given, the first definition is your directed angles. Okay. So what is a directed angle? So let us have a ray, that is O and A. Let OA be a ray. If I rotate this ray by a certain angle to a new angle, new position, that is your OB, then this angle by which your original ray OA is rotated to new position OB is called as your directed angle. And how do we denote it? Angle AOB. So this is your directed angle. See, the rotation is always one angle symbol and then the arc we have to put it. And now I can always define the other way also. Suppose if my OB is my original ray, and if I rotate OB into a new position which is along OA, so then the directed angle will be in the opposite direction. Okay, so in this case, your directed angle will be what? Tell me. BOA. So from here you can see, so this we are going, when we call the motion is along, the rotation is along the clockwise direction, we define it as a negative, and when it is an anti-clockwise direction, we define it as a positive angle. So if suppose angle AOB, we rotate it by an angle theta degree, then your angle B, directed angle BOA will be equal to minus theta degree, or angle AOB that will equal to minus angle BOA. Okay, therefore directed angles AOB is not equal to BOA because they change by the signs. Okay, so this is the directed angle. So now let us see when this direct angle can be equal. So when it can be equal? So when this rotated angle, when we rotate this angle by 0 degree, that means your initial position and the final position of the ray, if this is also same, it's B, if the angle between them is 0, then your angle AOB is equal to 0 degree. And angle BOC will be also equal to 0 degree, or you can put minus, 0 doesn't have a sign, so it will be again 0 degree. So in that case, your directed angle AOB will be equal to, sorry, this is directed angle, AOB will be equal to BOA. Okay, so whenever if you say directed angle AOB is equal to directed angle BOA, that means it will always means that it is the angle between them is 0. So this angle is called as your 0 angle. Okay, so now I can always have rotate. There can be always another way of I can do it. So this direct angle opposite. So now I have my initial ray A. So I take a positive direction, positive angle rotation. So I am going to rotate it by 360 degree. So this was my initial angle A. When I rotate by 360 degree, that is going to be new angle position is B. Okay. So here the sign is same. Because initial angle is 0, and then I'm going to take a positive rotation of 360 degree. But your initial position and the final position is going to be, direction is going to be same. So this angle you call it as a what angle? One rotation angle. One rotation angle. Okay. So similarly, I can instead of making one rotation angle, I can rotate the ray by 180 degree. So this is going to be your new angle B. So if this angle is 180 degree, combinedly this is going to form a line. It can extend from both the sides. Okay. So this angle is called as your, what's the name?
Straight angle.
Straight angle. Should always have a direction. Remember, always a directed angle will have a direction. Okay, if you miss this arrow, your marks will be deducted. Okay, and similarly, I can always have one more. If I can always have a 90 degree also. Correct? If I rotate it by 90 degree, so this angle is 90 degree, and then you call these directed angles as your
Straight angle.
right angles. This is right directed angle. Okay, fine. So these are the definitions of your directed angles. Now, so we saw for a directed angle, we always should have one reference ray, and the angle has to be measured from the reference ray, either in the anti-clockwise or in the anti-clockwise direction. In anti-clockwise, we call it as a positive rotation. In the clockwise direction, we call it as a negative rotation. So what a requirement is that there has to be one reference ray is required always, because the new ray we are going to measure from with respect to that reference ray. Okay, so now we can't have an arbitrary. Somehow you can have this one as a reference ray. Somebody will have no, I don't want this as a reference ray. I will have some other angle. This is my reference ray. Okay, in every case, my rotation angle is going to be different. So we need to have some common convention by which I have to fix up certain reference ray, and that rotation directed angle has to be measured from that reference ray. So what is the easiest reference ray is our coordinate system. Because we have this rectangular, this is called as rectangular coordinate system. I will explain why it's rectangular coordinate system when we discuss about the next chapter. I will discuss why we call it a rectangular coordinate system. So for this is a usual coordinate system we use. What is that we have? This is x, and this is going to be minus x, positive y, and minus y. Okay. So then I can always take my positive x-axis. See, the positive x-axis is a ray, right? Because this is my origin O. From origin to this array, I can always define this as my reference ray. So then, for any angle, so this angle is my directed angle OA. So the directed angle is XOA. Okay, so this is. So then I can have one angle, one ray along in this direction, or I can have another one ray along this direction. This is B, and I can have another ray. So this rotation angle will be this one, and then I can have another ray which is C, which is here, and then this rotation angle will be this one. And I can have another one ray also, something like that. This is D. So this rotation angle will be this one. So now you can see, so these rotation angles can be different. So it depends upon the ray. So here if you know, this ray falls on my first quadrant, and this ray falls on your second quadrant, and this falls on your third quadrant, and this falls on your fourth quadrant. Correct? So then we can call this angle as, this angle is the angle in the first quadrant. What's the name they call? Angle in the first quadrant, right?
Angles in the quadrant.
Angles in the quadrant, yes. So angles in the quadrant. What is this word called? So angles in the quadrant. So this angle is in the first quadrant. This angle is in the second quadrant. This angle is third quadrant. This angle is the fourth quadrant. Suppose if this angle, I rotate this angle to such that if this OA matches with my y-axis, if OA matches with the y-axis, then you call this angle as your quadrant angle. Similarly, if this matches with your x minus x-axis, these all angles are called as your quadrant angles. Now what we have are OX, OY, O minus x, and O minus y. These four angles are called as your quadrant angles. Okay, and then there's one more definition we have to use. So let me have this axis minus x. So let us have this coordinate system. This is what we call as a coordinate system. So this is your, okay. So now I am having an ray here. So this is origin, this is your A. So this is our directed angle in the first quadrant. Okay. Now, if I rotate this ray by, let me call this angle as theta degree. If I rotate this, it's always use symbol small o for the degrees. Okay. So if I rotate this angle by 360 plus theta degree, that means I am going to rotate it by 360 plus theta degree. So it's going to again direct it along the same line. Okay. So then this angle, this is going to be 360 degree plus theta degree. So, and what is something interesting about it? Because your initial ray and the final ray, they are going to have a same direction. Okay, so such angles is called as your coterminal angle. Now it is not just 360 degree. You can have one more rotation. Something like this I can have. I can have one full rotation, then another one rotation, and then I can stop it. Now this angle is 720 degree plus theta degree. Okay. Now the difference between my original angle, this is how much? 720. So then what happens? So then your difference. So let us call this final angle as A and this angle as B. A degree and B degree. So our difference A degree minus theta degree is equal to 360 degree. Correct? Similarly, B degree minus theta degree is equal to 720 degree, which is nothing but 2 times 360 degree. Correct? So in all this, I can have one more rotation. I can keep rotating. What is the condition? Your initial ray and your final ray should have the same direction. Okay? So that angle by which, whatever the angle I rotate, by which all the initial ray and final ray comes to the same direction is called as a coterminal angle. Remember, we are maintaining the same sign. We are not going the opposite direction. Okay? We are always taking a positive. So positive theta degree and positive 360 degree plus theta degree, or positive 720 degree plus theta degree, these all are going to have the ray on the same initial direction. Okay. So in general, if your angle, let me have any two angle, if your theta degree minus say some angle, I am going to call it as, what symbol we can use? Let me call it as C degree, something. It can be any angle. If this difference is n times 360 degree, where n can be equal to 1, 2, 3 or something like that. So then this angle you call as your coterminal angles. Okay? Fine. So now